Okay, so this is a brief rundown on how I want lab reports done for the purposes of my AP Physics classes. I put this together. It follows mostly the standard approach for lab write-ups, but everybody a lot of times has kind of their own take on things. I'll give you some of the distinctions in here. Now, I also have a document that I've made available on Edmodo that you guys can find. This is a sample write-up of a lab that I did years ago that is similar to one that we do in class, but you guys don't have to do a full lab write-up. On the front page, it helps to have simply a title page by itself, some sort of title for the lab, whoever is the author, so that would be you, and then lab partners, any of the partners that you have that work directly on the lab with you. And then instructor name, if you're writing it for me, Sanchez. And then the date, either the date you're turning it in or the date the lab was done on, something like that, but basically something in the ballpark of around the time when you did this. That way, if you look back in a couple of years, you have an idea of the rough period. I don't need the exact day per se. All right. The way that I put these together was based off of actual published papers as well. The introduction, the idea behind it, is not dissimilar to the abstract, although I do kind of remove some of the you summing up everything, and I have the other part of the abstract over in your conclusion. In the introduction, in short, you want to describe the experiment, why you performed it, and include either a hypothesis or a goal. We'll either have a hypothesis where we're testing something like Newton's second law, for instance, or for example, for the first one that you'll do a lab write-up, your hypothesis is that you can, by looking at smaller groupings of objects like note cards, you can predict what a large grouping of them, some of the properties. So things like the mass, okay? And we're going to test that hypothesis. Now sometimes in some of our labs we may not know enough about it to have a hypothesis formed. Sometimes we're going to do exploratory labs to see if we can find a relationship between how fast something rolls down an incline and something else, like maybe its mass or its size. And those are things that you would look into as a possibility. In the introduction, you basically introduce what you're doing and why you're doing it. Next section is materials. Describe any tool, any other device, anything that you're doing in the setup. Your goal should be to be descriptive. Anything that is key to collecting the data or recording anything that you need, try and include that. Not always good about including things like a notebook, but doesn't hurt to list that. If you can, try and draw a picture or have a picture of some kind. A picture is worth 1,000 words, anything that you can do. In the labs that we do, feel free to snap a good picture with your cell phone, with the image, and you can drop it right into the document that you're working with. That's fine too. The goal is to try and make it easy on someone to set the thing back up. Materials. I'm looking primarily for you to lay out what you've got in there and describe how it's set up, how it would be used, that sort of thing. Next section, procedures. Here's where you do a step-by-step layout of exactly what you did. I don't need you to be hit you over the head obvious, like, then you put the pen down. We don't need that, but your goal here is to make certain that someone could walk in and pick up your instructions and do pretty well at recreating the lab and collecting exactly the same type of data that you would. That's the goal here. Now, if I give you a printed up procedure, you are welcome to use my procedure if that describes what you did. If you made a few alterations, go ahead and use my procedure and add in your changes. If you use anything of mine, and if you use any pictures that you did not get, or that you did not take yourself in the materials, that's what the reference section is for. So keep track of that. Anything you get from someone else needs to be mentioned in the references. Data. This is where you record your raw data. Say what you've collected, although that's usually implied by the procedures and the setup. But if you can, try and have a table where you lay that data out. In the data section, my preference is to have only your raw data, things that you have collected. If you've done any math on them, try and hold those off until the next section, which is data analysis, discussion and analysis is the title that I'm going with on it. So here's where you present just your raw data. In the next section, in discussion and analysis, here's where you explain anything that you do with your data, any of the graphs you set up, any things that you do to fix the data. Maybe you had a systematic error where it added 10 grams onto every measurement. If you subtract 10 grams from every measurement, explain why you're doing it, and lay out clearly that that is what you're doing. That's in the discussion and analysis. You'll also start talking about some of your conclusions there, although most of that's going to be in the conclusion section. But anything that's pertinent to why you're looking at, oh, I then did this mathematically, or I did this other thing mathematically. In fact, I've got this in the background, so why didn't I bring that up? I'm showing you the page, but although you should have access to this document, it's on Edmodo. Let's see. And on this document, I have in parentheses kind of my description of it. This section explains what you do to the data to get useful information. This section also often includes graphs to help get across the important information. This section can also include any error analysis or mistakes that occurred during the lab. If you had anything that looked a little weird in the lab, this is where you would introduce it. Like I said, we think that the scale added 10 grams onto every measurement that we took. This is where you would include that. And you can start using this to predict what type of effects that would have on your data. All right, the conclusion. This one's worth quite a bit. This section is usually about one paragraph. I'm not looking for pages and pages on this. Sum up the whole experiment, kind of what you did, a restatement of the intro, except this time you include your findings and any possible future explorations that could build off of this. Maybe you think, hey, we could expand on this by now adding a time measurement. We could start recording that, depending on what you're looking at. We could use this to measure the force on something else. Things that we could then take what we've started here, make a small alteration, and maybe we're doing something entirely different. Other things that you can do, how to improve them. In the first lab, if you used my procedure as I asked you to, I mentioned when you guys did it that I left in something that probably isn't the best approach on this. See if you can identify what that is and mention it specifically here. Hey, in the future, we should do this differently. I think it would get us better results for this reason. Final thing that you need in the conclusion is either address your hypothesis or your goal. If you had a hypothesis that we can predict what something is going to do, did you actually predict it? Could you get within that? If not, talk about that. Say, no, our data doesn't support that. That's fine. I'm not grading you on whether or not your hypothesis proves right. The thing that I'm looking for, and pay close attention to this, is if your data does not support the hypothesis, tell me that. I've had quite a few people who their data does not support what they ended up with. And they tell me that, oh yeah, everything's great, we predicted it just fine. That's bad. Look at your data and see if it actually agrees. If it doesn't, tell me that and you have done wonderfully. I don't care if you've gotten the answer you were looking for or not. Tell me what you find with your results. If it's the goal, then say something like, we found that there was a relationship between how heavy the object was and how quickly it went down the ramp. Or, alternatively, we found no relationship. Mass seems to have no effect on it whatsoever. Both of those are possibilities. Look at your data to see what you come up with. In this section in particular, I'm not looking for right or wrong answers. I'm looking for what your data, what conclusions that brings you to. And finally, the references. Anything that you get from an external source, if you use my procedures, put in procedures from lab handout by Sanchez. You take an image off the internet, give me the URL where it came from. It's from Wikipedia or something like that. I'm trying to get you guys set up where you don't just take things off the internet. Give credit where credit is due. If you get something from one of your lab partners, maybe they made a dynamite setup diagram, or they took the picture and you get the picture from them, that's fine. Say, picture provided by lab partner. Specifically use that lab partner's name. Okay? But this is the breakdown and kind of the things in particular that I'm looking for. Data, for the most part, keep it to raw data, and when you start doing math, that goes into discussion and analysis. For the most part, your average lab report, maybe 3 or 4 pages. I don't need you to write me a book. Okay? Just make certain that it touches everything that we're looking at. There's also a rubric on Edmodo, so you can see exactly how I generate the grade off of this. So that's what we're looking for in a lab report.